Welcome back to the Science Hub SKB. Part 2. Indicators and the pH scale. Indicators. Imagine if we had a secret detective that could tell us whether something is acidic, like a lemon, or alkaline, like soap. That's what indicators do. They're like magical detectives. Indicators are used to tell whether or not a particular liquid is acidic or alkaline based on color changes. Some even come from nature, like red cabbage juice, turmeric, litmus from lichens, beetroot, hibiscus flowers, grape, or blueberry juice. Here's a table showing us how our indicators change when an acid or a base are added to them. Red cabbage juice turns red when an acid is added to it, and greenish yellow when a base is added to it. It stays purple if it's added to neutral solution. Turmeric turns yellow when an acid is added to it, and it turns red or orange when a base is added to it and stays yellow in neutral solutions. Litmus turns red when an acid is added to it, and blue when a base is added to it. It stays colorless in neutral solutions. Beetroot turns pink when an acid is added to it, and yellowish when a base is added to it. It stays purple or reddish purple in a neutral solution. The juice of hibiscus flowers turns bright red when an acid is added to it, and green when a base is added to it. It stays light pink or purplish in color when it is added to a neutral solution. Grape or blueberry juice turns red when an acid is added to it, and blue or green when a base is added to it. It stays purple or bluish purple when it is in neutral solutions. Please note that in neutral solutions, because they are neither acidic or basic, these are the original colors of the solution of the natural indicators. On the other hand, examples of indicators often used in the laboratory are litmus paper, universal indicator, which is a mixture of dyes, and methyl orange. These laboratory indicators change color when acids are added to them and bases are added to them. For instance, litmus solution turns red whenever it's added to an acid and blue when it's in a basic solution. It stays colorless in neutral solutions. Methyl orange turns red in acidic solutions and yellow when basic solutions are added to them, and it stays orange in a neutral solution. Screened methyl orange changes to light red when an acid is added to it and green when a base is added to it. It stays orange in neutral solutions. Phenolphthalein is colorless in an acid and pink when base is added to it, and it stays colorless in neutral solution. The same stands when these indicators are added to neutral solutions. They do not change color. These are their original colors because neutral solutions are neither acidic nor basic. However, simply knowing if a substance is an acid or base does not give enough information about its strength or impact. And from this, knowing its strength or impact gives us an idea on how safe a substance is and how it can be handled. The exact level of acidity or basicity is crucial for different purposes, such as adjusting soil for farming, mixing chemicals in labs, or ensuring the safety of products like shampoo. The pH scale. P stands for potens in German, meaning power or potential, and H represents hydrogen ions. Hence, pH stands for potential of hydrogen or power of hydrogen. It is a measure of the concentration of hydrogen ions in a solution. The pH scale indicates how acidic or basic a solution is. The pH scale is a number scale going from 0 to 14, which indicates whether a solution is alkaline, acidic, or neutral. On the pH scale, 0 to 6 refers to the acidic scale, 0 being the most acidic and 6 being the least. Substances with a pH of 7 are neutral, meaning they are neither acidic nor basic. The pH range 8 to 14 is alkaline. Page 14 is the most alkaline, while page 8 is the least. You can find the pH of any solution using universal indicators. The pH of a solution is the measure of hydrogen ion concentration within a substance. The more hydrogen ions present in a substance, the more acidic it is. The universal indicator changes from green to a different color depending on the pH of the solution you place it in. The pH meter. Using a pH meter is often preferred over a universal indicator. Why is this? Well, this is because it provides precise numerical values, making it more accurate. Color changes using indicators can be subjective and less precise. It also works well if the solution being tested is colored or opaque. Indicators can be unreliable in colored or cloudy solutions because the color change may be masked. pH meters also give consistent readings if calibrated properly, while indicators can vary depending on the lighting or observer's interpretation of colors. Additionally, pH meters can be reused multiple times after proper cleaning and calibration, while indicators are single use. New indicator solution or paper is needed for every test. Comprehension. What is an indicator? List 3 plants that can be used to make indicators and list 3 indicators that are often used in the laboratory. Indicators are used to tell whether or not a particular liquid is acidic or alkaline based on color changes. 3 plants are hibiscus, red cabbage, and turmeric. And 3 laboratory indicators are litmus, phenolphthalein, and methyl orange. Comprehension. What can be used to detect whether a solution is an acid or a base? What color would litmus paper turn in tannic acid? And define pH. An indicator can be used to detect whether something is an acid or a base. Litmus paper would turn red in tannic acid. P stands for potent in German, meaning power or potential, and H represents a hydrogen ion, hence pH stands for potential of hydrogen or power of hydrogen. Comprehension. Lists 2 advantages of using a pH meter as opposed to an indicator, and what is the pH scale. A pH meter provides more precise numerical values, and it is more reliable when it comes to determining the pH of opaque or colored solution or substances. The pH scale is a number scale going from 0 to 14, which indicates whether a solution is alkaline, acidic, or neutral. Comprehension. Determine the color change that would occur if the following indicators were used to test whether the solution is acidic or alkaline. Congratulations, guys and gals. I know you did an awesome job. So the trick to this is, first you needed to state what the solution was, whether it was a base or whether it was an acid, and then you were supposed to know litmus solution turns blue in a base, red in an acid, whereas phenolphthalein turns pink in a base and it stays colorless. There's no color change when it's added to an acid. So for sodium hydroxide, because it is a base, upon addition of litmus it would turn blue, and upon addition of phenolphthalein it would turn pink. Hydrochloric acid, upon addition of litmus solution, it would turn red, and phenolphthalein would have no color change. Because sulfuric acid is an acid, it turns red when litmus solution is added to it. It stays colorless when phenolphthalein is added to it. Calcium hydroxide is a base, so it turns blue when litmus solution is added to it, and it turns pink when phenolphthalein indicator is added to it. And with nitric acid, the final one, it changes to red when litmus is added to it, and it stays colorless when phenolphthalein is added to it. Great job. I'm so proud of you. Okay, so finally, use the pH scale to determine if the substance is acidic, alkaline, or neutral. When Susan added universal indicator to the liquid that she was testing, it turned orange. The liquid is A or N. Universal indicator is naturally green. When it was squirted into a solution that was transparent, the solution remained green. The solution is A or N. Have a gander, have fun, answer it the best way you can. Congratulations! So looking at the pH scale and the color scale that matches it, you would see that if something turns orange, that's on the acidic side, so it is definitely an acid. And indicator is added to a neutral solution and there is no change in color, that means that the solution is neutral. So because the indicator, the universal indicator, remained green, we see that there was no change in color, it didn't affect it, so therefore the solution that it was squirted into is neutral. Next one. So Victor tested the solution's acidity by placing a pH meter within it. The meter showed a pH of 13.9. The solution is ARN something. And universal indicator was squirted into a liquid and it turned blue. The solution is ARN something. Have fun! Do you have alkaline for both? So yes, even though we don't have decimal places on the pH guide above, we can still determine that it's within the region of 13 to 14, which is alkaline for C. And for D, if the liquid turned blue upon addition of the indicator, we know that it's alkaline, which is also basic. So therefore, yes, that solution is definitely alkaline. Thanks for joining us for part 2 of acids and bases. See you around for the last part. Bye!